Afternoon, sir.
Good
Good
afternoon, sir.
afternoon, sir.
Good afternoon.
Good
Good
afternoon,
afternoon,
sir.
sir.
Good
Good
afternoon, sir.
afternoon. Good afternoon. So, just a minute, okay? Just 1 minute. Are you able to see the screen?
Yes,
Yes,
sir.
sir.
Okay. Just a minute. Then it is fine. Everything is done. Okay. So, today we are going to start new chapters, that is kinetic of particles. So, last day onwards in dynamics we have done only kinematics. So now today we are going to start a new chapter, kinetics. That is relationship between the unbalanced force and the change in motions that they produce, like acceleration, decelerations, velocity. So we are now dealing with the relationship between unbalanced force with respect to the change in motions. That indicates the Newton's second law, like P equal to mf, that expressions. Now, so when we are talking about any force as per the Newton's second law, a particle will when particle will accelerate when there will be some unbalanced forces. And this kinetics is the study of the relations between unbalanced force and the resulting changes in motions. So it is 3.1, 3 by 1 article in Merriam-Craig dynamics. Okay. So now So Newton's second law says that when we are dealing with some force and it is posing some accelerations, say for examples, then there will be some ratio. There will be some ratio like P equal F equal to F by F1 by A1. For one unbalanced force F1, acceleration is say A1. Another unbalanced force F2, acceleration say A2. And these accelerations, in what directions you will apply the force, acceleration also will be in the same directions. Say F3 and corresponding acceleration say A3. And then this ratio becomes some constant. This ratio becomes some constant that depends on the units used for measurement of the force and accelerations. So if somebody is using force say for Newton and acceleration say meter per second square, then this ratio, this unit, here you will get some unit, that unit depending upon that in what units you have used for force and accelerations. Now, for the ratio of the applied force to the corresponding accelerations equal equals to a same number. Okay, when you are providing same units you used for measure, provided the unit used for measurement are not changed in the are not changing. Don't consider here experiments. So this is the some ratio. That ratio means that some invariable property of the particles. The C is some invariable property of the particle. This property is nothing but inertia, that is giving the resistance to the rate of change of the velocity. Okay, when it says when this acceleration is more, then what force is more, acceleration will be less, and vice versa. And now this this ratio, actually basically this ratio C or this value C, we are giving as that quantitative measure of the inertia. We have given the mass, and also we can have P equal to mf or F equal to mf. That relationship you have learned before. Now whenever we are solving in kinetics, there could be three ways to solve any problem. Directly we can apply that Newton's second law, which is called force mass acceleration method. Force mass acceleration method, or maybe we can use work and energy principles, or maybe we use impulse and momentum methods. Using these three general approach, we can solve the problems of kinetics. Now, definitely, whenever you are defining some systems, there can be some inertial systems. Due to the inertia, we are talking about no mass is the representative of the inertia, so there will be some inertial systems. Now, when we are talking about now equation of motions and solutions for these problems, one is say we can directly use summation f equal to ma. Basically, this f summation f, maybe fx, fy, fz in three-dimensional case, all summations we are talking about. And acceleration may be x, ay, and az. But acceleration is unique. There is no case of summations, correct? Acceleration is unit. Okay. And this is equation of motion we can use. Now, for solving this type of problem, we may have there are maybe two types of dynamic problems. One is accelerations of the particle is either specified or can be determined directly from the known kinematics conditions. So B equal to say U plus AT, or some relationship we can directly, either this acceleration is given or maybe we can directly calculate from this kinematic relationship. Once you know this acceleration, then you can calculate unbalanced force equal to m multiplied by a, mass you know, acceleration you know, and you can calculate the relationship and force. Okay, and this type of problems are very straightforward, very simple. But in the second type problems, maybe force acting on a particle are specified. Force is given, and we must determine the resulting motions. It is very carefully you can check this F is nothing but resulting force. this F is resulting force. If this resulting force is zero, then acceleration is zero. So either particle will be at rest or it will be with the constant velocity in a straight line. Okay, and it will move in a straight line. When there is some F unbalanced force present, then there will be some accelerations. Now, when this type of problem force is given, then we can calculate the resulting motions. Okay, if force is constant, then acceleration is also will be constant. Okay, and when force is varying with the time, then maybe some integration point of integrations you have to perform carefully. Okay, that's all. Now, motion can be constant motion. It has been constant, or it may be unconstant motions. It is free. The way we have learned the constant motion in problem sheet 5. Okay, so it may be unconstant motion or it may be constant. Then here, apart from that kinematic relationship, here we have force to acceleration relationship. Say for example, okay, and it may have 1 degree freedom, 2 degree freedom, or 3 degree freedoms. Okay, okay. Now, when we are talking about rectilinear motions, when we are talking about rectilinear motion in a straight line, movement in a straight line, okay, in 1D case, so it is along x direction, then this is the relationship summation fx equal to m ax. Okay, and this summation fx may be one is f, f1, f2, f3. Okay, and maybe this is the x, this is the y, and maybe this is z. So there maybe exists that in both x and y and z directions we have resultant force. Then we are expecting acceleration in all x, y, and z directions. Okay, x, y, and z directions, and we can easily write that this acceleration is component wise x, ay, az, or maybe this is a magnitude. So resulting force, okay, resultant force may also have component wise like this, and this is the magnitude. Say this is one example when that car collision test has been shown where there will be huge amount of accelerations and that will be accompanied by large force contact forces, okay, throughout the system of the two cars, and there you can see some car dummy at there. Here you cannot see. Then they are also subjected to large force preliminary by shoulder harness or seat belt restraint. So there will be some seat belt as an arrangement, so that dummy also are expecting some large forces. This is called crash worthiness, WORTI, worthiness problems, or we call impact problem. This is the nothing but impact problems. Okay. Now let's take one simple examples. There is a small inspection car. This is the small inspection car that is having mass of 200 kg, that is running along the fixed overhead cable. This is the fixed overhead cable. This is the fixed overhead cable, and that is controlled by attached cable at A. This is the A, and this is one cable has been attached. So whenever some force has been applied in horizontal directions, but due to some inclinations of this fixed overhead, it will this small inspection car will travel along these directions. Okay, determine the accelerations of the car when control cable is horizontal and under the tension of 2.4 kilonewton. 2.4 sorry, yeah, 2.4 kilonewton tension. This is given. We have to calculate accelerations and also total force P exerted by the supporting cable on the wheel. Okay, here these are the some wheels. There will be some reaction forces. What is that reaction force? We have to calculate. Now you can see this is nothing but roller support. So whenever you have roller support like this, okay, This roller support, okay, roller support will give some force along this perpendicular directions only. Now draw the F body of inspection card. Okay, let it be x directions, it is y directions. Now, as the problem says that it is 200 kg mass, it is passing through center of gravity, and W equal to mg, and g equal to 9.81, then it is around 2 kilonewton, 1.962 kilonewton. That is the force acting vertical directions. So this here, this reaction force exerted by the supporting cable on the wheels, say it is P, perpendicular directions. Okay. Now it is given this is 5 by 12. From this you can get the slope. It is 12 here and it is 5. Okay. If it is 12, it is 5. Then definitely we can write this one similar way. This is a 12 and 5. Okay. Here what is been shown, let it be x and y directions, we can consider inclined also. Let concentrate this x and y. Now it is, if it is 5 by 12, it will be this way, 12 by 5. Now if I consider this as a x, this as a y, in y direction there is no accelerations. In y direction, these directions, there is no acceleration. So Fy equal to 0, summation Fy equal to 0, equilibrium in y directions will be this P minus, here it is W, or somebody can calculate from this theta also. Okay. Tan theta, then theta also you can consider. So if this is a cable, this is, if this is theta, then this also will be theta. Okay. So now from the concept of sin theta and cosine theta, so 5, 12, then it will be 13. So sin theta is 5 by 13 and cosine theta equal to 12 by 13. Okay. So this is P minus W in kilonewton, okay, multiplied by cosine theta. So this minus this minus T component, okay, 2.4 kilonewton T component. So if it is theta, this also will be theta. So this is cosine theta, so this will be sin theta. Okay. So P minus T, here it is P minus T sin theta minus W cosine theta equal to 0, summation Fy. From this you can calculate value of P. You have to be careful here, 2.4 kilonewton, and this one we can write 1.962 kilonewton, same unit. Such that P will be in kilonewton. Now in x direction there will be some accelerations. Say in accelerations, summation Fx equal to m ax, ax equal to a. Let's see, x equal to a. Then along that directions, use equilibrium x direction equation of motion, not equilibrium, because here there is some unbalanced force. So this is mf. Okay. Then this is along that directions. This here it is T cosine theta minus W sin theta. This is cosine theta. This is sin theta equal to ma. You can you can check this. This is Newton. This is Newton. Okay, and this is your kg. Such that acceleration will be in meter per second square. and that is 7.3 meter per second square. So you can solve based on this type of problem. So what we did, carefully we have drawn motion, it is rectilinear motions along a straight line. And what we did, based on the given problem, we have drawn equilibrium equations in y directions and equation of motion in x direction. And x and y are inclined here. Okay. Why this way we have considered? Because then easily we can write this max, that accelerations along that. If I use this is the x and y, then there will be some component also along that x and y. It will be difficult. It will be more cumbersome. Let's to make it easy, we have considered inclined x and inclined y. That's why I told in exam I will never assume that x is in horizontal direction. Summation you used to write summation fx0, but you have not shown x and y coordinate. It is a big issue. But I don't know which one is horizontal or which one is vertical. Okay, next problem. There is a 200 pound, this is unit is pound, 200 pound block A, M A. This is block A is released from rest in the position shown and pulls, it is pulling 400 pound log. So this is a B, yeah? MB equal to 400 pound. It is pulling and it pulls the 400 pound log. This is the wooden block kind of things. It is a log and it is moving up with the 30-degree incline. If the coefficient of kinetic frictions mu k, okay, 0.5, then determine the velocity of the block as it hits at the ground. So VB equal to, we have to calculate at S equal to 20 foot, 20 feet. Okay. So we can write the statement like this. Now you can, what you have to do, you have to draw this constant equations from this to this. I am not using this because already it is constant. So it is SC and maybe this to this it is SA. So this plus this. Okay, twice SC length plus SA plus some constant, that is the length of the cable. So length of the cable is twice SC plus SA plus some constant. And if you do the derivative, then acceleration, then you will get this relationship. 0 equal to 2AC plus AA, or you can write AA equal to minus 2AC. That means when this is because when SA length is increasing, SC length will decrease. That's why this is the relationship. AA acceleration of A is twice of the acceleration of C. Okay, twice of the acceleration of C. Now, so one is positive, other is negative. That's all. Which one is increasing? That is positive, and which one is decreasing? So basically, this AC is basically negative value because it is moving down. Okay, and your this AA will be positive value as it is length will increase. Okay. So now if you want to draw the free body diagram, this is 1, this is 2, and this is free body diagram 3. So in free body diagram 3, here it is straightforward that there will be some force here and some T here, tensions, and if it is T here, it will be T and it will be T. T, this is 2T, and then this one will be 2T. So so this is intermediate free body diagram will ensure that when this is the tension T of the cable, here it is 2T. So this free body diagram 2 is important for us. Don't skip this. Don't keep FBD 2. Okay. Now we got, yes, we got this 2T. Now, if I draw here, this is the x directions, then this is the y directions. Okay, and in these directions, a acceleration of a b. This direction it is a b, and for this case, acceleration will be these directions a. Here, due to this contact, there will be some reaction force N. As it is moving upward directions, there will be friction downward directions. And it is having 400 pound mass, it is 400 pound. Okay, let's consider this as the x and this is the y. Or rather, I will do, this is x and this is y. Okay, this is, anything is fine. Now, if I want to draw free body diagram for FBD1, Fy equal to 0, because in y direction there will be no accelerations. So n minus, okay, maybe we can do this exercise. Basically, if this is theta, okay, then this also will be theta, this also will be theta. So n will be, sorry, n minus 400 cosine theta, theta equal to 30 degree. Yeah, I have written here before. So n minus 400 cosine theta equal to 0, or n equal to 346 pound. Note, we are writing force as a pound itself. Force I am not converting to poundal. Let it be pound itself. Okay. Now, for this problem, accelerations in the its most equation of motion in the x direction, because as this is the accelerations, so we cannot write equilibrium equation. It is the equation of motion along the x direction. Let it be sign reverse. So this is plus t 2t minus plus 2t minus 400 sine theta. Yes, along this 400 sine theta, then minus mu n equal to mc, this is c, correct, mc ac. What is mc ac? If ac we want to write in foot per second square, then we supposed to multiply some pound with respect to 3.32.2 foot per second square. Acceleration due to gravity 32.2 foot per second square. Okay, either this 32.2 you have to multiply here and here, or you can just divide this and write these expressions AC. Okay. Now, if you move to this block FBD3, then 250 minus T equal to 2 M. This is MA. Okay. Equivalent MA. I should not write MA. Actually, this 32.2 supposed to multiply here, because we want T also in terms of pound. Okay. So if I divide this, then this will be the relationship. Now this is the expression 1, this is expression 2, expression 3. Three equations. From these three equations, 3 unknown can be calculated. That is A, that is this is the A positive moving down, increasing, AC decreasing, because FC length is decreasing, then T is 205, T equal to 205. Now somebody can check if T equal to 205 tension. Okay, and we have considered that it is moving down, correct? Whether it is moving up or not, you can You can check that one also. But before that, let's consider determine the velocity of the block when it hits the ground. Okay, when it hits the ground. So v square equal to 0 square plus 2ax. A is the acceleration of ax. So if you write this ax, then you can get the velocity when it hits. Now, some hints you can see very important for any of the problems this book has provided. The coordinates used in expressing the final kinematic constant relationship must be consistent with those used in the kinetic equation of motions. We can verify that the log will indeed move up this log by calculating the force in the cable necessary to initiate the motion from the equilibrium conditions. This force 2t, this force was to initiate that was 2t equal to, okay, 2t was 0.5 multiplied by n plus 400 sin theta, and that is 3, and that will give t equal to 186.5. That means when t equal to 186.5 pound, then so initially t is 0. So what we can assume that you are holding here and you are putting using some force by your using hand. Some t equal to 0, then you are increasing t. When t equal to 0, it will be in static conditions. Now increase the t, and once t will be 186.5 pound, okay, this will just try to have the motions. Okay, before that it was at rest. Then if p is 207 pound, then this will start accelerating due to the unbalanced force along the along that right side directions. Is it okay, this problem?
Yes,
Have
sir.
you? Yeah, yeah. So next problem. Okay. Let me check how many problems I have. Okay. Okay. Now there is a collar of mass m. This is the collar of mass m that is slide up. It is slide up, means this is the acceleration directions. Slides up the vertical shaft under the action of a force F of constant magnitude but variable directions. This if F is constant, theta is varying. Constant magnitude but variable directions means theta we are changing. Now maybe this relationship theta equal to kt, where k is some constant, and if the collar starts from the rest with theta equal to 0, okay, t equal to 0, theta equal to 0. Determine the magnitude f of the force which will result in the collar coming to rest when theta equal to pi by 2. Okay, determine the magnitude of f of which will result in the collar coming to rest when theta reaches pi by. So finally v equal to 0, theta equal to pi by 2. We have to calculate at that case what is the force. Okay. Now you draw the FBD carefully. Okay. And coefficient of friction mu k is given. Now as it is moving upward directions, so you can expect your friction force is acting downward directions. And cell point of the collar will always will act in downward directions mg. Okay. Now force you have applied, this is the theta. Okay. Now if you are pulling like this, if you are pulling like this collar, if you are pulling like this, then which direction contact will happen? One or two. If you pull here, okay, if you pull along that directions, in upward directions, which directions, which case is that contact supposed to happen?
One. One.
1, correct?
Sir, one side, sir, left
Yes,
side.
yes, yes, yes. I don't know why it is these directions. Don't worry. We can change this to here. Hmm. We can change this to here. So it will not affect anything. Don't worry. Okay. So now whatever the value they have given, if I continue that one, that uh, movement movement is such that along this direction it will move. So let it be. This is the positive y. Okay. This is the positive. Sorry. Moving up.
Sir, actually
Yeah.
that normal should be outward of the contact now.
Tell me.
Hello, sir.
We
Normal should be outward perpendicular to the contact now, sir.
now that see that perpendicular is fine. I'll tell you. What color? I can change the color. See, this is the part. Oh, sorry. This color I will not understand. You cannot differentiate. This perpendicular is okay. I have no doubt of it. This is the perpendicular direction. Now, question is whether these directions or these directions. If I move this color,
Sir, towards outward of the contact now, sir.
no, you imagine this. You are see there is some vertical shaft. You are holding this and you are moving this, and you applied some force, tensile force these directions. Then what will happen? This side will be in contact, is not it? Or this side will be in contact. What
Okay.
you understood? Contact. Say there is there is some feet, some
For
gap.
one.
One, correct? That's why I'm telling. This is one. This is
Yes,
supposed
sir.
to be one, but it will not affect your final expression. Don't worry. I'm just telling that say something happened due to the friction. Some wear happen. Say this is the mechanism people are using. Some wear
Okay.
happen. You are the designer. I'm showing the cross section. So this is the cross section. Okay. If wear happen, we are supposed to happen here. Wear and tear. Okay. This zone because this will be contact zone. Understood?
Yes,
So
sir.
design will be such that this side will be
Yes.
should be strong for this case. So here the drawing is like this. Okay. But in this engineering mechanics, this problem it is not a big deal. Don't worry. So what I am doing then as y this direction it is moving. This is the positive y. Then this f cosine theta minus frictions mu n mu k basically minus mg equal to mf equal to mf. Now what is told that that is done sir y directions. Now if somebody want to calculate along the x directions, okay, along the x directions, then you have f sin theta equal to n. F sin theta minus n equal to 0 or n equal to f sin theta. Now it is told that theta equal to kt. Now if I write this f cosine theta equal to kt minus nk sorry mu k n is f sin theta. This is the f sin theta is equal to kt minus mg. Okay, minus mg. Then dt equal to mv. So this m dt dv dt, this dt I want to move here. So this is the dt and this is dv. Velocity is changing from 0 to v. At initially it was 0. Initially it was 0. From rest it has been told. Yeah, starts from rest. Okay. Now if you do this integration, this will be the relationship. You may look that only y directions we have considered. To solve this x direction, we have not done anything. Okay, x direction we have not done anything. So that is the reasons. So which direction n is acting, that is not important. Okay. Okay. So now next is, if this is the expression, if somebody want to put theta equal to 0, sorry, v equal to 0 when theta equal to pi by 2. So theta equal to pi by 2 equal to kt, then corresponding t equal to k pi by 2. Okay. T equal to, am I doing anything? Yes, I'm doing mistake here. Pi by 2k. Yes, pi by 2k is the t, and velocity equal to 0. You write in these expressions. Okay. Velocity theta equal to pi by 2. This is 1. This is 0. Okay. Then t equal to pi by 2k. You write this expression. Finally, you will get corresponding force required. So what we did, we just simply draw. We have drawn the free body diagram, and based on that, based on the free body diagram, we have equate in y directions uh, Fy equal to MAY. Okay. Then uh, in x directions, just a minute. In horizontal directions, we got n equal to f sin theta. Then there is one issue. Okay, let me tell you. Very peculiar problem. Okay, just a minute. I'll erase and I'll show you. Okay. Here, this is a theta. So this f sin theta in horizontal directions, correct? F sin theta, f sin theta minus n equal to 0. If I consider n in these directions, if I use n in these directions, then equilibrium equation says f sin theta minus n equal to 0. That means n is this direction. If f is positive, if f is along that direction, then n supposed to be along that direction. Or if it is other directions, then contact will be n will be in different directions. So this relationship, once this relationship is valid, n equal to f sin theta, then n is acting left directions. Why it is left directions? Okay, if I use this positive and I am putting this, okay, one thing. Okay, we have to assume one thing. Say this is the collar shaft. If I apply this F, try to understand this F, then contact will be here. Confirm, correct? Is not it? Try to understand. Then contact will be here. Now, I am applying F like this is some theta. Here it is some F I have applied along this theta. Now, when theta equal to 0, I understood this will be the contact. But based on the theta, either this side will be contact or this side will be contact. That I don't know initially. Based on this theta value, okay, when this is theta equal to 0, when theta equal to 0, and we are pulling this, so there will be contact here. There will be contact here. So on this, this will be the reactions. Here, I am drawing the free body diagram here. If I put this side, then at this face from the inner side, this will be the reactions. Okay. This will be so these reactions, what is being shown here, it is not here, it is here. I'll highlight once again. If we have any doubt, I'll clear this. Contact is here. Here, this here is the contact due to that force. But this is the hollow one. This is the hollow one. So I am drawing here. This is the hollow one. So this is the contact. Contact is here. And if I apply force, force like this, so this is the contact, and this will be the reaction force here. That reaction force is shown here. Have you understood this one? This one, you just consider this hollow one. We told this side and this side. Left side is the contact. That is true. But as this is hollow, this shaft is giving reaction this side. How to show that one? We are showing this left side. It is coming from the left side. Don't be confused that it is applied here. No, it is no, not here. Here, it is here. This reaction is here. Have you understood this point now?
Yes, sir.
Okay, fine. Next is curvilinear motions. When we are considering curvilinear motions, the way we did for rectilinear motions, these are the relationship. Rectangular coordinate. This was x, this was y, but here it was, this is the n and this is the t, tangential and normal and tangential coordinate. This is the tangential direction, this is the normal directions. In rectangular coordinate, this is summation fx equal to max, summation fy was may, and x equal to x double dot, ay equal to y double dot. In normal and tangential case, summation of an equal to man, summation of ft equal to mat. Only thing, initially in kinematics, we have the we have here 0, correct? Something we have here 0. For static problem, we have here 0, this was 0, this 0, 0. But here in kinematics, we have the accelerations. And we put it is in the right side. And this an equal to v square by rho, or there will be some other format. At will be v dot, velocity dot, and v equal to rho v dot. V was the radius of curvature in radian. Now, in this present syllabus, we are not covering one topic, that is polar coordinate. In polar coordinate, also fr equal to that will r theta coordinate basically, and fr was mar, f theta equal to ma theta, where ar is relationship is this, r double dot minus r theta dot square, and alpha, this is a theta equal to r theta double dot plus 2 r dot theta dot. I am just giving for your information. It is not in the syllabus. No question will be asked from this. Okay, now let's take one example. There is one small object that is released from rest, v equal to 0 at a, and it is slide down on the smooth circular surface for friction equal to 0 of the radius r to the conveyor belt basically b. It is moving from this to this smooth on a smooth radius of curvature surface basically. Determine the expression of the normal contact force n, between the guide and each object in terms of theta, and specify correct angular velocity w of the conveyor pulley, this pulley, of radius r to prevent any sliding on the belt as the object transfers to the conveyor. This type of conveyor belt you have seen that some objects will move and it will from one place to other place it will move. Now at particular instant, if this is the things we going to draw the FBD free body diagram, so its mg will act vertically downward and along this will be normal force. It will normal force means this is the n normal direction, this is the n, and let's have this is the t direction, this is the t, and so what are the things here? There is no frictions. One is not this force, normal force, self weight, and it is having some accelerations at. Okay, and at is along this. Now, if somebody want to write that motion equation of motion along tangent directions, summation ft equal to mat. So, if this is theta, so what we can have, this is theta, then this is theta, this is also theta. Okay, so it is theta means this also will be theta. So along t directions, it is mg cosine theta, mg cosine, as this is theta, mg cosine theta equal to mat, at equal to g cosine theta. Now somebody can use vdv equal to atds, vdv equal to atds, 0 to from starting from velocity 0 to some velocity v, vdv, this is the a, this is the at, theta is varying from here, theta was 0, so theta 0 to theta, and what is ds, ds equal to d r theta, s equal to rt, that way, ds equal to d r theta, r is constant. If r is constant, r will come out, so it will be d theta. So cosine d theta will be sine theta. Then it will be v square by 2, which the 2 is here, this is g, this is r. Okay, somebody can have v equal to square root 2g r sine theta. Okay, now regarding the normal force n, so it is along the normal direction, summation fn equal to man, so it is n minus mg sine theta, yes, equal to m omega square r or v square by r. Somebody write omega square r or v square by r. That relationship we can utilize, we can get n equal to 3 mg sine theta. Now when this block has come here and it is omega is the speed, omega rotation speed, then v equal to omega r, v will be related to omega r, and that velocity v is same as square root 2 gr sine theta. This is basically v equal to omega r. To avoid the slide, when theta equal to pi by 2. So this is 1, this is 1, sorry. This is 1, so omega will be 2 g r capital R by small r. Omega equal to square root 2 g capital R by small r. So what we did for the given problem, we have drawn the correct COD diagram along tangential directions and normal directions, and we have equated that to get the desired unknowns. Okay, so it is not straightforward one, little bit cumbersome, not cumbersome, conceptual we can say. Next problem. So relative motions 3.12 10 plus 2 standard, same concept. When we have this RA, RB, and relative velocity is relative positions. This is the positions RA, RB for B, RA for A. Some summation of F is acting there. So relative velocity of A with respect to B is position is R relative equal to RAB. That is this. So and doing this derivative, somebody can have this form: absolute acceleration A equal to absolute acceleration B plus relative accelerations of A with respect to B. Okay. Now somebody can utilize this small a by this relationship to get this. Once again, somebody can utilize the Newton's law. Once you will solve the problem, you can easily understand this. Now, last point is D'Alembert principle. This is based on the French mathematician D'Alembert in 1943. He told that Newton's second law of motions is not only applicable for the particle, but also it is applicable for the three-dimensional body. And summation f equal to ma, that can be replaced by summation f minus ma equal to 0. That means till now what we did that this way, summation f was ma. He told this is not only valid for particle, but this is valid for three-dimensional body also. And he told it can be replaced by f minus ma equal to 0, such that right side it was 0. Right side this value was 0. How he has proposed this one? Let some m mass, and it is some summation f, and this is the acceleration. So he told that in the direction acceleration will happen, in the reverse direction there will be some reactive force. We call some reactive force. So he told summation f minus ma equal to 0. This way we can write, and minus ma may be considered as the force of magnitude, same as, okay, magnitude and acceleration, but in opposite directions of the motions, and it is termed as the inertia force or reverse effective force. And he states that system of forces acting on a body in motions with dynamic equilibrium, with the inertia force of the body acting opposite to the motions. So he has given new concept called dynamic equilibrium. What is that? Say I'm simplifying the problem. One block, some n, some force you have applied. This is the mu n. Maybe acceleration is this a. So he told as it is moving and mass is say m. Okay. Sorry. Then directly I can write here mg. Okay. This is the mg. Acceleration is along this. So he told in the direction of acceleration in reverse directions, we can have some reactive force, that is ma, same as that ma we wrote. And he told, and if this is the x, then some, and this is say y. So we know that summation fy will be n minus mg equal to 0, n equal to mg, and summation fx equal to 0, that will be related to like this: f minus mu n minus ma equal to 0. So that idea is given, that right side we can write as a 0, and this is called dynamic equilibrium. So what we can have, right side it is 0, then whatever the directions inertia force will act, in reverse direction some pseudo force will consider in the free body diagram. Many times this idea, this consideration can eliminate some confusion in drawing the free body diagram many times. Okay. Now let me tell that, say there is one string, there is some mass, and it is having some rotational speed. It is rotating, so omega. Okay. Now at any instant, we can have n normal and some y direction. This is the tension of the cable, say. This is the weight of the mass. Then, of course, some centrifugal force will act like this and outside directions. Okay. So instead of writing this right side, what we can do, we can move this and we can write, maybe some books write this way, dotted 1 m omega square r, such that summation fn equal to 0, we want to write that that minus, sorry, this is the positive n, sorry, t, so t, we have applied t that directions, t sin theta, t sin theta minus am omega square r equal to 0. So here what we have written at that time, fn equal to man, okay, fan, but here we are writing fn equal to 0, although it is dynamic problem with some acceleration, but we can write this. How? Because this accelerations we have considered by the pseudo force using D'Alembert principle. Have you understood this one?
Yes, sir.
Okay, done. Then what we can do, we can solve some of the problems from the problem sheet. Okay, so what I have provided already, I have provided 6, 7. Let me check how many assignments I have provided. I think 5 are remaining. So I have provided you, it is not as assignment, study material. I have provided this 3.4 problem sheet, 6, 7, 8, 9 is missing, 10 and 11. 5 problem sheet I have provided to you. Now if I go back, it was problem sheet 11, rectilinear motion. That one we will do first. Then other one, problem sheet 7. So problem sheet 11 first, then problem sheet 7. Come back here. Problem sheet 11 is the last one. Okay. Let me show you 1 or 2 problems for each one. Say problem sheet 1. 11 first problem. It is simple to start with. For this problem, what fraction n of the wheel, sorry, what fraction n of the weight of the jet airline is the net thrust required? What fraction n of the weight of the jet airplane is the net thrust required? That net thrust is nothing but T minus air resistance. Okay, required for the airplane to climb at an angle theta with the horizontal with an acceleration a in the direction of flight. In the direction of flight, this problem is given. Now, what we can do? Just one information I want to say, that this, okay, let me change the color, maybe this. Okay, this T is the thrust that is produced from the engine, nozzle thrust. Engine will give this, and due to this movement in the air, there will be some resistance R, we call drag. This is the drag force. Okay, and there will be one force which is perpendicular to the this we called airplane uh, airplane plane, basically some perpendicular some force, that is called lift, LIFT. So there will be some lift drag and its self weight will be always downward, W. Okay, and it is making angle theta here, that indicates let me change color. Okay, okay, so This is also theta. This is also theta. This is also theta. Okay. Now this is the x direction. So summation fx equal to 0, or this direction it is moving, this is the acceleration. So we can consider using D'Alembert principle, this is the m. Okay. Then we will write T minus R minus W sin theta minus m is W by G A equal to 0. So we are using D'Alembert's principle here. Or maybe W by G multiplied by A, you can put right side. So this is the expressions. Or T minus R, here T minus R equal to W multiplied by sin theta plus A by G. Now T minus R by W equal to T minus R by W equal to sin theta plus A by G. Okay. Sin theta plus A by G. Now what is T minus R? That is the net thrust T minus the air resistance. Net thrust T minus R. If R is higher than the T, then it will not flight will not move forward directions. Okay, it will move in reverse directions. So net thrust required, what fraction of the weight, what of the jet airplane is the net thrust required for the airplane to climb. That means T minus R by W, that value it has been asked. Now this sin theta plus A by R, very nice expression. You can have some idea when theta equal to 0, horizontal direction it will move. Okay. Then it is this ratio is nothing but A by G. Acceleration A, G. A is acceleration of the acceleration of the jet by acceleration due to gravity. So many scenario it can come. Okay. So let's solve this. Then maybe I solve this problem. So this problem, there is 1.8 kg collar. Yes, this is the collar that has been released from the rest against the light elastic spring, which has the stiffness of, here it is talking about the stiffness, unit force required to produce unit displacement. Okay. F by delta equal to stiffness, load displacement curve. Slope of the load displacement curve is the stiffness. So what it has been told for this problem, stiffness K, that is given as 1750 Newton per meter. 1750 Newton per meter. And has compressed a distance of 150 mm. So it has been released from one position, actually 1.8 kg collar. Let me write m equal to 1.8 kg. This is the collar. Okay. Is released from rest against the light elastic spring, which has a stiffness of this and has a compression and has been compressed a distance of 150 mm. So at a distance 150 mm compression, it has been released. Determine the acceleration A of the collar as a function of the vertical displacement x. So vertical displacement is x. So yeah, it is given. This is the x. As a function of vertical displacement x of the collar measured in meters from the point of release. Find the velocity v of the collar when x equal to 0.15 meter. Same 150 mm. This friction is negligible. Okay, that means say if I have this way, so this is the first conditions, unstressed conditions. Okay, roughly I am drawing this. Maybe this is the ground. Okay, so this is the spring. We can say this. Let me. This is unstressed conditions. Then what it has been told that it is been compressed by 0.15 meter and released. It is compressed and released. And this is the positive x directions. Okay. And maybe at this instant when it is x, let's have this compression is delta. I mean to say when delta equal to 0, it is released. Which is released? This collar will be, this collar will be not in touch. Okay, or maybe I can draw here itself, you will understand better. So let's draw.
Hello, sir. Can I ask something?
Yes, sure.
Sir, the spring is hollow, right?
Okay.
I mean, the rod is inside the spring.
Yes, I'll actually I'll tell. This one is, this cross section is like this. Okay. This one. This is the sign. It is, this collar is hollow. Then this is the shaft. This is the shaft cross section. Okay. Now this spring is connected something here. This is the collar. You see the collar bottom. You concentrate this. This is the cross sections, and this spring is connected here. I'll change color. Maybe here. Understood? Okay, yes, I'll tell you. Many times you have even your pen is having some spring, correct? Dot pen.
Yes, sir. Tip top pen.
Tip top pen, same thing. So you consider, okay, that is the tip top pen, and inside this is the refill. Understood? That way you compress it and release it. If you try, okay, then what will happen? If you compress little bit the spring and release it, spring will leave from this that length. Okay, correct? It will move away. Yes, it's a similar problem. Yes, similar problem. Okay. So that, see, if I draw here, maybe this is the unstressed conditions, and this is the stress conditions. Maybe 1 minute. Okay, I'll draw this. It's not this exactly. This is the stress conditions, and this is the unstressed conditions. I'll tell you why I'm telling that way. This is 0.15 meter. Okay. Or maybe if you have any confusions, I will modify once again. Don't worry. Let it be, this is the time when it is been released. So this is basically direction of x. This is the maximum value, and maybe I am considering. So I'm measuring everything here. Okay, and maybe I am considering, say, this is one state. What I did, this one from initially, this is unstressed. Actually, it was initially like this. Then I move here up to this 0.15 meter. Then I release. And if sometimes it is the from this distance x, and this is say delta at that instant. Then x basically 0.15 minus delta. When t equal to 0, it is been released. Then delta was 0. Then x equal to 0.15.
0.15.
Yes. When delta equal to 0, then means when delta equal to 0, then which location you are? You are here. Is not it? Delta equal to 0.15 means you are here. Initially, delta was 0.15. But when delta equal to 0, sorry, when delta was 0.15, x was 0. When delta is 0, means you are here. Then x equal to 0.15. This is the two extreme case. Initially, delta 0 was 0.15 meter. Okay, initially. Velocity was 0. Now, you tell me what force it has been applied at any instance here. Two force basically. One is its self weight mg. Other is it is some reaction force from the spring, that is F.
Spring force.
Yes, F spring. Then it will move upward directions. So acceleration is this, and as per the D'Alembert principle, ma is along this. Okay. Now we'll act that way. That what is the spring force? F spring, that is equal to k delta. K multiplied by delta. Is not it? Delta equal to 0.
Yes, sir.
Yes. Then spring force is 0. That is 1750 multiplied by 0.15 minus x. When x is measured in meter. X is measured in meter. When x is in meter. Why it is meter? Because I have converted this into meter. So this is the spring force. Now, what is that? X direction summation fx 0 D'Alembert principle. Okay. So minus 1.8. This is the mass multiplied by 9.81. This is the weight in Newton, plus 1750 multiplied by 0.15 minus x minus 1.8 multiplied by acceleration equal to 0. Is not it? It is a ax. It is told it is AX basically. Okay, answer wise it is AX. So we got from this simple, correct? So AX you will be getting expression as 136 minus 972x. This is the expression of the accelerations AX. Okay, any doubt?
No, sir.
Okay. Now
No,
once
sir,
you will
got it.
get, yeah, yes, yes. Once you will get AX, so what we will do, V dV equal to A dx. AX dx, acceleration AX dx. So V dV equal to 136 minus 972x dx. This integration is starting from 0 to V, and this is acceleration. X was initially 0, finally x was initially 0, is not it? You see this figure, x was initially 0, 0 to 0.15.
0.
Yeah, then you will get velocity 4.35 meter per second. That's all. So what we have utilized very carefully, we have drawn free body diagram. So don't forget to write MPD free body diagram along the vertical directions. We have used some trick definition of the stiffness, force required for unit displacement. That is based on that spring force we have calculated, and we have drawn the free body diagram in the y directions using D'Alembert principle. Everything left side, right side is 0. Then we got acceleration expression function of x. Then v dv equal to a dx. We have utilized that expressions, that kinematics relationship, and to get the velocity v. Okay, so 2 problems I have solved. Remaining problem you do. Then we will see. 1 minute. Then 11 is over. Then next, as I told, let me come back. Problem sheet 7. 1 or 2 problem I can solve today. 7, correct? Yeah. Yes. Okay. Okay. So, say problem 1. Okay. Skateboarder negotiates the surface down here. Okay. As shown here, negotiate the surface shown. His mass center speed theta equal actually v0, v45, v90. It is given 0, 6 meter per second. It is 45. Sorry, 8.5 meter per second. This speed it is given. Determine the normal force between the surface and the skateboard wheel. The skateboard wheel. If the combined mass of the person and the skateboard is 70 g, so 70 kg here, and mass center is 750 mm from the surface, from this to this 750 mm, and this is the radius of curvature. You can see it 4.5 meter. Okay. Now we can draw one single free body diagram to get the expressions for the remaining. So what we can do, here also, here itself I will show you. Sorry. So this is the point, say, okay. So this is the W, and this is the normal reaction N. Okay. So without friction, he cannot move and moving upward direction. So let it be some friction F here. Okay. And this distance is rho. Rho equal to 4.5 meter minus 750 by 1000 meter equal to 3.75 meter. Okay, rho. So if I consider this is the n normal directions and summation mn equal to 0 using D'Alembert principle, then I have to use the pseudo force concept also. Okay. So and its acceleration is n. So this is the pseudo force MAN. Okay. MAN. So Fn equal to 0 will be An minus W equal to 70 multiplied by 9.81 Newton. N minus W. Now coming to theta. Which one is theta? I think this one is theta. If this is theta, then this also theta. If this is theta, this also theta. Okay. Now it will be N minus W, this is theta. So W cosine theta now. Okay. Minus M V square by rho. V square by say rho or 3.75 equal to 0. This is FBD. Kindly show this friction force. Okay. Don't skip either downward or leftward, but you should show that. Otherwise, that fellow cannot move. Okay. Okay. Then we will get from this n equal to 70 multiplied by 9.81 cosine theta plus v square by 3.75. It will be Newton. Okay. Now you put theta equal to 0. Okay. If you put theta equal to 0, then V0 equal to, I have written somewhere, 8.5. Okay. And theta equal to 45 degree, V0 equal to 6. Not V0, V equal to 6. Theta equal to 45 degree, 90 degree, V equal to 0. So you can get corresponding n value, 2040 Newton. Here 1158 Newton, here n equal to 0. So last case n equal to 0, because at that case your velocity itself is 0. Now you just utilize this figure and you will get that values. Okay. One is done. Then maybe
Sir, 5, sir.
yes.
Sir,
7, 5.
problem number 5, sir.
Okay, very good. Actually, this is related to polar coordinate. Initially, we have new one problem sheet 4, that, and also 9, which is missed. Okay, we have excluded this part. Long time back, 10 years back, 9 years back, we used to cover. Okay, due to time issue. So don't worry, this problem will not be come in the exam. Okay, because if I want to include this, then that portion will is very lengthy and conceptual. So we have intentionally removed two problem sheet 4 and problem sheet 9. By mistake it has come here, but here we have to utilize, as I am telling you, some polar coordinate things I have shown somewhere. Yes, not covered in the syllabus. Okay, this it has come by mistake there.
Okay,
This
sir.
actually this accelerations ERAT you have to utilize, this ERAT you have to use, but as I have not covered that, let it be excluded from the syllabus. Fine. That one problem will be excluded. Next one,
Okay, sir. Okay, sir.
one problem I'll solve. Time is short. Okay, this problem 4. It is better. So a small object, you can see small object of mass m that is placed on the rotating conical surface at the radius shown. This is the radius. Okay. If the coefficient of static friction between the object and the rotating surface is 0.8, mu k 0.8, calculate the maximum angular velocity w. This is w max you have to calculate. The object will not slip. Assume that gradual angular velocity change. To try to understand this type of problems, when there will be some rotational speed, if suddenly you have given some higher value of rotational speed, this block, the small block, suddenly will move away. Okay. So it is told to assume that very gradual angular velocity change. Okay, some vibration problem will be involved if you do it suddenly. Slowly we can do. Now if I want to draw the free body diagram of this, this will be self weight mg. This will be the reaction force n. Okay. Now there will be some, due to this movement, due to this rotation, there will be some centrifugal force involved. Okay. And that force, okay, if I write, the two way I can write in terms of D'Alembert's principle, one, other is normal equation of motions. Okay. Now in normal and tangential directions, if I draw here, let me draw this first. Which direction will be just a minute, color change. We understood that this is y direction. Now normal direction, what will be the normal direction? Directions. Horizontal, left side or right side?
Sir, right.
Right.
Towards right, correct? You mean to say this? Correct.
Yes, sir.
This,
Yes, sir.
yeah. If this is the case, this way you are moving. So if I want to write in terms of D'Alembert principle, so then which direction I should write that force with arrow?
No, sir. This work towards left.
Which one?
The D Elambot
Principle.
principle.
No, first of all, tell me whether this normal is correct or not. N direction is correct or not? Okay, I will
Yes,
write.
sir. Yes, sir.
Yes, yes, this is the AN, correct? This is the AN for this. This is the AN,
Yes, sir.
isn't it? If acceleration is this 100%, pseudo force will be this.
Yes, sir. M omega square R.
Right, MAN. Okay.
Yes, sir.
Because we know N directions confirm, AN directions confirm, then this is the case. Then friction, which direction?
Sir, upward.
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 F equal to mu n. Okay. Limiting case we are calculating. Now what will happen if omega is more?
Sir, the object will slide upward.
No, no, no. It will go away. Nothing is.
It will go out of the.
What problem you told? That is true
Yes,
here.
yes, yes.
Okay. That is true here. Because there are some object to resist even if your speed is high. But here nothing is there. It will go away. The problem you told, it is valid for this. Okay. There will be one W minimum and W maximum. The problem you told, it is valid because this is the AN direction and there is some material to give the resistance. Okay. Some material is there to give the resistance.
Okay.
But it is open. So it will go away. So for this case, if I draw the free body diagram, and this is the theta equal to 30 degree. So summation Fy equal to 0 will give n cosine theta minus mg plus mu s n sin theta equal to 0, and summation f n equal to 0, D'Alembert principle. Okay. Then it is n, correct, minus n sin theta plus mu n, sorry, not mu s, it's actually mu k. Okay. Let me wait. Sorry, static frictions. If I use mu k, it will move. It will go away. Mu s n cosine theta minus, okay, minus, is not it, m omega square r equal to 0, minus n component is minus, friction component is plus in positive n, yes, minus this. Now you have two equations, equation 1, equation 2. From this you solve. W will be square root G by R mu cosine theta minus sin theta by cosine theta plus mu sin theta. Okay, that's all. So remaining problem you can solve. Okay. So next day I will start. Next day means, let me check. Today is 15th. Okay. On 15th I will start new chapters. That is yes, work and energy, work and kinetic energy, work energy principle. Okay. And what I have planned, 2022 will be your class test. Okay. It will be for kinematics only. I will give you one day break. 25th there will be no class. Okay. 15 will be work and energy. 22 will be class test 2. 18 is holiday. 25th I will give one break. So we will resume on after 22. We will resume on 29, for impulse momentum, and this one for that impact problems. Then what you told, what is the plan to come to the college? Which date you will start?
Sir, from 6, sir.
Okay, 6 onwards. You will from your home, correct?
Yes, sir, from 6.
Now, who are outstation? What they will do? Which date they will come?
Sir, they have told, sir, from 6 onward, they will open the hostel for us.
Okay. Before that, there is no option to actually now there are many works are going on in classrooms, that cleaning that hostel preparations, everything. So hopefully by 6, if any student can come, they can accommodate, or else it will not be ready if it is before that. Correct?
Sir, is it compulsory to join offline?
Which case?
Sir, I mean the exams.
It is governed by institute rule. I cannot say this. There will be some senate meeting, governing bodies meeting. They have decided for this exam end semester. Which one? End semester, correct?
Yes, sir.
They told that it will be offline exam. Okay. This is governed by or decided by the governing committee of the institute. I cannot comment on that. Understood? Okay. So, see, I don't worry. There are. I will tell you what is happening. If it is online exam, question pattern will be one way, one type. If it is offline exam, question will be in other way. So, those who are working hard, for them, offline exam is better. Okay, because questions will be very easy. So we can directly take any problem from any book and means problem sheet, and we can give you. But here in online, we are not able to do that due to everything is open to you. All sources you can have access. Understood? Question pattern will be different. Question will be more tough, much tougher, tough than the offline exam if it is online. So, and whatever the institute will say, I have to follow that. Okay, that's all.
Okay, sir.
Okay, then as per your understanding, fifth. Okay, fifth, you can attend the class. Okay, is not it?
Sir, I think on
Yes.
5th we are
Yes,
on the
sir.
road.
Huh?
We are on the way. Sir, we are on our way, sir, on
Oh,
5th.
you are on the way. Okay, then maybe then, yeah.
Sir, we might take any extra class.
No, I'm not talking about that. Actually, exam will be from 18, correct?
Yes, sir, 18 to
Yes,
22.
sir.
Okay, so only one. See, one this week. What I have planned, that this 15 will be your work energy. Then 22 will be your exam. 25th I don't want to take class. Let's have one day break. 29 will be momentum, and first will be impact. Then one day I required, only one day. You tell me which day after one, which day will be comfortable for you after one. 1st April. Any one day is required. Which date you want? If you want 18, I can give a 12.
Sir, we can discuss and
8 is right.
Uh-huh.
8 is right, sir.
8 is fine, correct? Oh, 8 is fine or 2? No, 8 is fine.
Sir,
No,
sir.
no, sir.
No, sir, 12, sir.
No, don't think
No,
from
sir.
my side. There are
We
other
have
subjects
from
also.
8.
Yeah.
Sir,
Okay,
sir,
12,
before
12.
college
Yeah.
reopening, the classes must open.
18, sir. 18.
Hi, 18 is exam. Somebody is telling what? Tell me.
So I think before college reopening, the classes must be over. I think the notice, something like that was written.
Oh, okay. I have not checked. Then 5th.
It's the 5th is the only option.
The 5th.
Sir, you
Actually,
can
see,
choose.
no,
I
no,
think,
then
sir, you
fifth
can
is
choose.
fine. No, see, if there is any notification, I cannot go beyond that. Okay. Uh, Actually, syllabus will be over by April 1st itself. Only if you have any doubt, anything, for 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 kinetics only we can discuss, because kinematics nothing is remaining, everything I have solved, and some problem you have solved. Then I don't think that, do you need any portions for from the static?
Set 2 will be fine.
2 means?
Yes, sir, Saturday, like second
Second
Saturday.
April.
Okay, second Saturday,
Yes,
right?
sir.
Okay,
Yes,
fine.
sir.
Okay, so what we'll do, we will decide later. Okay. So
Yes, sir.
this is also good suggestion.
So
Let
mark
it
my
be.
attendance.
I have not taken any attendance till now.
Sir, can you start the attendance, please?
Yes, sure, sure. Let me check attendance sheet. Just a minute. Okay. AMB 25 present, 26 present, 27, 28, 29, 30. Okay. Then CEV 77 present, 78 absent, 79, 80, 81, 82, 83, 84, 85, 86, 87, 89, 90. Up to 90 present. 91 is absent. Just a minute. 92 is absent, 93 absent, 94 absent, 95 absent. Then CST 58 absent, 59 absent, 60 absent, 61, 62 present, 63 absent, 64 present, 65 present, 66, 67, 68, 69, 70. Up to
Sir, can I
7.
leave right now?
Yeah. No, not all, only you. Because then I cannot take attendance. Okay. Just 1 minute. Then 70 is also present. Then electrical 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. All present. Electrical. Then electronics 35 present, 36 absent, 37 present, 38 absent, 39 39 absent, 40 present, 41 absent, 42 absent. IT 53, 54 present, 55 absent, 56 present, 57 present, 58 present, 59, 60, 61, 62, 63, 64 present. Then mechanical 49 absent, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60 present. Okay. Just a minute. Then MMB 25, 26, 27, 28, 29 present. 30 is absent. Then mining 20, okay, just a minute, 27, 25 absent, 26 absent, 27 present, 28 absent, 29 present, 30 present. Those who are absent, once again, civil 91, 94, 95, CST 58, 59, 60. Then 36 electronics, 38 electronics, 39 electronics.
Sir, electronics 36 present, sir.
Just a minute. 36 present. Okay. 38 absent, 39 absent, 42 absent electronics. IT 55 absent. Then mining 25 absent, 26 absent, 28 absent. That's all. Okay, guys. Thank you. See you next week. Bye.
Thank you, sir.
Hello, sir.
Thank you,
Yes,
Hello, sir.
yes.
Yeah,
Good evening.
sir.
Ah,
Hello, sir. The
ah.
exam of 22nd is on kinematics.
sir.
Only kinematics.
Only kinematics. Yeah.
Okay, sir.
Sir, can
Only,
you repeat the date?
yeah.
Sir, can you repeat the date? Which date you will not take the class?
I
On
25.
25.
25.
That week let it be break. Yeah.
Thank you, sir.
Yes, 25. So
Maybe,
regarding yeah. Anything you want to tell? Anybody? Any
Nothing,
question?
sir.
No. Okay. Okay. Fine.
Yes, sir.
Yeah. Okay. Bye.
Thank you, sir.
Thank
Have
you,
a
sir.
good day.
Thank you, sir.